Hi dear students, this is Sanal from Physics Login. Welcome to the past paper practice series for CAE AS and A-Level Physics. Today we are going to solve Cambridge International AS Level Paper 2, 2024 February March. Okay. First question we will check. This table consists of some SI quantities. Complete the table by indicating with a tick mark which row are SI base quantities. Okay, base quantities. What are the base quantities? This you should memorize. Mass, length, time, current, temperature, amount of substance, intensity, right? They can give different combination. With this combination, what is given? Current, you can see that it is a base quantity, and the mass is a base quantity, and these two, energy and force, both are derived quantities, right? Okay, that was easy question. Second one, use the definition of power to determine it's SI base unit. Okay, definition of power, what is that? Power is equal to work done per unit time. So what is work done? Force into displacement divided by time. So this one will be force, you know the unit, kilogram meter per second square. Mass into acceleration multiplied by distance we measure in meters divided by time in seconds. Now we can rearrange this unit. So it will be kg meter square. Second will go to the numerator, so it will be second to the power minus 3. Okay, you understood? Whenever you are getting, they are asked for the derived units, you write the formulas and write the unit separately, rearrange it in this form, you will get it. Okay, is that clear? Okay, next question we will check. C part, a light meter is used to measure the intensity of a light in classroom. A daylight is incident normally on the sensor meter. Okay, the sensor has an area. Area is given 2.2 centimeter square. The reading on the meter is what? 950 watts per meter square. Watts per meter square. You can check the unit. Calculate the power of daylight incident on the sensor. So this watts per meter square is the unit of intensity. Okay, intensity, you need to remember this equation. Energy per unit area per time. Okay, so from here you can see that energy by time is what? Power. So this is equal to power upon area. What is the question here? Calculate the power of the daylight incident on the sensor. So P is equal to I multiplied by area. So I is given that 950 into area. Area is 2.2 centimeter square. So centimeter square you need to convert. So 2.2 into centimeter conversion 10 to the power minus 2. This you need to square, okay, because it is centimeter square. So when you put these values in the calculator, 950 into 2.2 into 10 to the power 4, right? So it will be 0.21. So answer is power, is unit is watt. So you can write it as 0.21 watts. Okay. So we'll move on to the next question. Part B, an Olympic diver stands on the platform above a pool of water as shown in the figure. The figure is given, the measurements are given. So we will read the question. When the diver is on the platform, his center of gravity is vertical height of 9 meters above the surface. So here, when he is at this floor, you can see that the center of mass is 9 meters above the surface. Okay, that is given. The diver jumps from the platform with a velocity 5.9 meter per second at an angle 60 degree with the horizontal. 60 degree with the horizontal, it is given in the question. So the air resistance is negligible. Air resistance is negligible. When the diver hits the surface of the water, his center of gravity is vertically at a height of 1.2 meter above the surface of water. So that means the moment he is hitting the ground, hitting the surface of the water, Center of gravity, you can see that it is 1.2 meter above. So that is a key point in this question. You can know that it is 1.2 meter above the surface of water. Calculate the speed of the diver at the instant he hits the surface of water. So when he hits the just that instant, you need to find out what was the speed. So when you check this one, so every object, in kinematics and dynamics, whatever object they give, we will consider the motion of center of mass only, okay? Center of gravity only. If velocity means an object is moving with a velocity means, even if it is a train also, you will consider it as a point object. That point is the center of gravity. The motion of center of gravity, if you're calculating acceleration, actually you're calculating the acceleration of center of mass. Force is applied on the center of mass, okay? So for kinematics and dynamics, you will remember this point. Here also, you need to consider the motion of the center of mass. Look at this one. So when he jumps, what happened? This point will follow a parabolic path and it will reach here finally, okay? But, excuse me. But when you check this one, the question is when this body touches the water, what is the position? So that means you need to find out the motion. You need to consider the motion at this point. Okay. So you know that this is 1.2. So the vertical velocity, if you want to find out this distance only, you will take it as displacement. So 9.0 minus 1.2, which is equal to 7.8 meters is your displacement. This one we will take, okay? So during the downward motion, we will consider the y-axis motion, y direction motion. Y direction motion, if you consider. So it has a velocity at an angle theta. So first thing, you will resolve this into two components, right? So what will component will be here? 5.9 adjacent side. So cos 60 will be here. Here it will be 5.9 sine 60. So to these two components are responsible for the motion of that center of mass in x direction and y direction. Look at that. It has a motion in x direction and y direction simultaneously, a projectile motion, right? So you want the x direction. X direction, what is the initial velocity? So you can write it as x direction initial velocity is equal to 5.9 sine 60, right? So 5.9 sine 60. Then acceleration is 9.81 meter per second square. The displacement is, you need to remember 9 minus 1.2 you need to take. It will be 7.8 meters. All these values are there. What you need to find initial velocity, acceleration S, you need to find out the final velocity, right? So time is not there means only one equation you can use. What is that? V square minus U square equal to 2AS, right? So you substitute the value you want, V square, which is equal to U square plus 2AS. U square is equal to 5.9 sine 60, the whole square, plus 2 into 9.81 into 7.8. Okay. When you put it in the calculator, you will get the value as V is equal to 13.3. Okay. 13.3 meter per second. So you're getting the velocity. The question is about the speed. Okay. So at this point, you check this one. This is the important point. At this point, it has a vertical velocity downward, which is 13.7. And it has a horizontal, because in projectile, you know that x direction, there is no force because we didn't consider the air resistance here. There is always a horizontal component of velocity, which is constant. Why? There is no force acting in the x direction. The air resistance is negligible. So this constant value is there. What was that? 5.9 into cos 60. 5.9 into cos 60. So these two, what is the two velocities are there, right? In x direction and y direction. What is the speed, magnitude, the resultant of this one, right? The resultant of this you need to find out, that is the speed. Okay, speed you can find out using this one. So it is a right angle triangle, you can use Pythagoras theorem. So what will be the resultant speed, resultant or magnitude of velocity? So speed is equal to root of 13.3 square plus 5.9 cos 60 square. If you put this in calculator, just check what is the value. 0.6 into 10 to the power minus 7. So you're getting 13.7. So you need to round off to two significant figures. So it will be 14 meter per second. Understood? So one more method is there to solve this question. You check this one. This also I will explain. Since there is no air resistance, negligible, you just check this one. At this point, it has a velocity. That means there is a kinetic energy, right? Half mv square. So what happened? This will follow a projectile path. When it reaches this position, what happened? It will have the same kinetic energy, right? So this initial kinetic energy, what is that? It is moving, it is gaining potential energy at this point. It will have the maximum potential energy. Then it will come down. When it reaches here, it will have the same kinetic energy given at this point. Along with that, which is traveling through this displacement means the potential energy is converting into kinetic energy, right? So this is the kinetic energy final. If you're taking kinetic energy final, so kinetic energy final will be equal to what is that? The potential, the kinetic energy at this point. What is that kinetic energy? Initial plus this potential energy is also converted into kinetic energy, right? mgh. The final kinetic energy was what? Half mv square. This v you need to find out. That is the question. So which is equal to initial kinetic energy. Initial kinetic energy is half m. What is the velocity given at this point? This one is 5.9. When it is reaches here, the same kinetic energy it will apply. It will attain because there is no air resistance, right? So this will be 5.9 the whole square plus m into 9.81 into what is the height? Height is this much is the height change. Center of mass only you will calculate, right? That is 7.8 meters. 7.8 meters. So you can cancel m from all. You solve for this v square. You will get the same answer as 14 meter per second. Okay. So you can check this method also. This is easy method. If you know the concept, this is conservation of energy, right? There is no friction, no air resistance. What happened? The kinetic energy given, it is converted into potential energy at the maximum point. Then what happens? It will, again, it reaches the same height. It will gain the kinetic energy given at this position. Along with that, some more kinetic energy it will get, which is the conversion of potential energy. So this method also you can use to solve this question. Okay. Next question. The diver in B enters the water and decelerates. Describe and explain the variation of the viscous drag force acting on the diver in the water as he moves downward. Okay, so it is, you need to explain the variation of drag force. Drag force variation you need to find out. Okay, so you know that it is decelerating. One more thing is that it is decelerating. So as the diver moves inside, what will happen? The speed, deceleration is that the speed of the diver will decrease. The viscous drag force is always directly proportional to the speed. If speed increases, the force will increase. If the speed decreases, the force will decrease. So what will happen? What will be the variation? Here speed is decreasing. So definitely the viscous drag force will decrease. Okay. So you can phrase it as the diver moves in the water, down there, speed of the diver decreases. Viscous drag force is directly proportional to the speed. So drag force decreases. Okay, you can phrase it like this. Next, the diver has a volume of 7.5 to 10 to the power minus 2 meter. The density of the water is given as 1 into 10 to the power 3. Show that the upthrust acting on the diver when he entirely under the water is 740. Okay, the upthrust acting on the diver you need to find out. So you consider that equation. What is the equation for upthrust? Upthrust is equal to V rho G, right? The volume V is the upthrust formula, the volume of the solid immersed in water. Rho is the density of the fluid, right? So when you substitute the value, volume is given 7.5 into 10 to the power minus 2 multiplied by density 1.0 into 10 to the power 3, and G value is 9.81. When you put this in calculator, you will get 740 Newton. Okay? Understood? Now, next part. At a particular instant, when the diver is entirely under the water, his horizontal velocity is 0. The viscous drag force acting on him at that instant is 950 Newton. Okay? So 950 Newton is the viscous drag force acting on it in the vertically upward. It is given as vertically upward. The diver has a mass of 78 kg. Determine the magnitude and direction of acceleration of the diver. So acceleration and magnitude and the value, direction also you need to find out. So you consider at a particular instant, they are given that there is a force acting. What is that force? Viscous drag force acting in the upward direction. So I'm writing it in terms of simples. FD I will take. And one more force is there, right? What is that? Anyways, weight is acting. So weight W is acting downward. And one more force is there, upthrust force. Okay. So upthrust is also acting upward direction. Now, you can see that these values are given in the question. So upthrust value, what we have calculated, right? Upthrust value is 740, drag force is there. The meaning is upward force is 950 plus 740. Downward force, weight 778 is the mass multiplied by 9.81, right? So there is a resultant force. So this is the result. One is acting upward direction, one is acting downward direction. Definitely an unbalanced force is there. So you can say the F resultant force is equal to what? F is equal to mass into acceleration, right? Acceleration will be there for the body. So you can substitute. So what is acceleration? The resultant force upon mass. You will get the acceleration. What is the resultant force? Upward force 950 plus 740 minus 78 multiplied by 9.81 divided by mass is 78. Okay, if you put these values in calculator, do it. So the acceleration you are getting is 12 meter per second square. Okay, so your answer is 12. You know that what is the resultant force? The resultant force is in the upward direction because upward force is more. So what is the direction? Upward. So we will move on to the next question. A thin metal wire X of diameter 1.2 into 10 to the power minus 3 is used to suspend a model planet as shown in the figure. Okay, you can see the figure. And the variation with the strain of the stress for wire X is, okay, stress versus strain graph is there. So stress versus strain graph, it is obeying Hooke's law, straight line, right? So you will get the gradient is Young's modulus. Okay, remember that. Let's check the question. So the strain in X is 5.4 into 10 to the power minus 3. Use the figure 3.2 to calculate the, okay, you need to use the figure. Okay, this figure you have to use to calculate the force exerted on the wire by the model. Okay, so force exerted by the wire, the strain energy is given. So you know that what is Young's modulus? Young's modulus E is equal to stress upon strain, right? So from here you can find out sigma is equal to Young's modulus multiplied by strain. So you require the calculate the force exerted. Force sigma definition, what is that? Force upon area, which is equal to E into epsilon. So stress in a modulus of elasticity multiplied by strain. So you can find out F from here. F is equal to E A into strain. So here you need to find out what E from the graph. You need to use this graph. So you can find out the gradient first. When you find out the gradient, which point you can take, which one is easier? This one, right? 6 is easier, right? 6 from here, 8 exactly. So you can use this point, 8 and the 6. So take that values from the graph. So the gradient equal to what? Young's modulus. So this will be equal to 0.8 into gigapascal, right? So into 10 to the power 9 upon 0.6 into 10 to the power minus 3. So when you put it in the calculator, 0.8 divided by 6, which is equal to 1.33 multiplied by 10 to the power minus 3 will go there. So it will become 10 to the power minus 11. So correct, 10 to the power 11, okay? So this is the Young's modulus. Then you can area also you need to find out. Area is what? Pi by 4 d square or area formula, because it is a uniform wire, right? Pi by 4 d square, or you can write pi r square also, okay? So this will be E value you got, what is the value? 1.33 into 10 to the power 11. Substitute in this equation, 1.33 into 10 to the power 11 multiplied by pi by 4. The diameter is given. What is the diameter? Initially it was given 1.2 into 10 to the power minus 3. So 1.2 into 10 to the power minus 3, the diameter whole square, right? So area you got multiplied by strain value is given. What was the value? 5.4 into 10 to the power minus 3. So 5.4 into 10 to the power minus 3. When you put all these values in your calculator, you will get the answer force as 1 minute, 1.33, 810 Newton. Okay. So 810 Newton is the answer. You have to use this one, okay. Use figure 3.2 means the other method also there. You can use one more thing, the corresponding stress you can find out, right? 5.4 is the strain and corresponding stress from the graph you can find out. Then you can equate F by A is equal to that value. That also you can do, okay? The elastic potential energy of X is 0.31 joules. Calculate the original length of the wire before the model planet was attached. Okay, so there is a strain means change in length will be there. Before attaching, what is the original length? For to find out that they have given the potential energy. What is the formula for elastic potential energy? Half fx or half kx square, right? This x is the elongation or compression of the wire. Okay, so here what you can use the first equation because you have the force. So 0.31 equal to half into 810 multiplied by this x is the change in length, right? You're taking it as delta x. So when you solve for delta x will be equal to 2 times 0.31 divided by 810, right? If you cross multiply, you will get it. So when you are solving this value in calculator, you are getting 7.7 into 10 to the power minus 4. And this is the delta x only, the change in length. What is the question? The original length. What is change in length and original length direction? The strain. Strain is equal to delta x upon x. So you want x means x is equal to change in length. You already got 7.7 into 10 to the power minus 4 divided by the strain value 5.4 into 10 to the power minus 3. 5.4 into 10 to the power minus 3. So when you put this in calculator, you will get 0.14 as the original length. Check in calculator. Now, the wire X has replaced by a new wire Y with the same original length, diameter, but double the Young's modulus X. So only change is the only change is happening in the material. The remaining all are same. So draw a line to represent the variation with the strain and stress on Y. Okay, listen, look at this one. You just doubled the Young's modulus. So Young's modulus from the graph, if you check, Young's modulus is the gradient, okay? If you double the Young's modulus, what happened? The gradient should be double, right? So if you draw a line greater than that value, you will get 1 mark, but you need to find out the exact value. It should be, the gradient should be double. So when you check this calculation, if you want to make this value double means you can reduce this to 2. You divide it by 2. What happened? This 2 will go to the numerator and the value will get doubled, right? So what was the initial 0.6? You just mark it as 0.6 divided by 2. It will be 0.3, right? It's not 0.6, it was 6, okay? So 6 divided by 2, it will be 3, right? So 3 you take, and strain value you didn't change, right? You divided 6 by 2 only. So 8 you mark, 3 and 8. When you mark, you will get it here. Then you can draw the line. So it should pass through this point, okay? You draw a straight line which is passing through 8 and 3 and 8.8. Draw a straight line which is passing through this. This will be the draw a straight line, okay? The next question, a nucleus P undergoes a alpha decay to form another nucleus Q. Complete the equation for the decay. So alpha particle means what? He plus plus, right? Helium nucleus. He24. So 2 and 4 comes here. So when you check from 84, 2 is gone as alpha particle. So the charge will be 82. On the mass number, when you check, 2015 nucleons were there. From that, 4 is gone in alpha, right? So it will be 2, 1, 1. So if you get both correct, you will get 2 marks. State the principle of conservation of momentum. What is conservation of momentum? The total momentum of an isolated system of bodies will be constant. If there is no external force, what happens? The total momentum of the system remains constant. So that is the principle. You need to write it. You need to phrase it properly. total momentum of an isolated system of bodies. Isolated, the meaning is no external unbalanced force. Okay? The total moment of an isolated system of bodies is constant. Understood? So, next part is, before the decay, the nucleus P has a speed. Okay, a speed is there. After the decay, the nucleus Q is stationary. Calculate the speed of the alpha particle after the decay. So there is no external force acting in the system, right? And this is moving with the velocity from that an alpha particle is emitted. So the momentum before and after should be same. Then only total momentum of the system remains constant, right? So you can write the before the emission. What is the momentum? That is momentum of P should be equal to, after the collision, what are the particle? The momentum of Q plus momentum of alpha particle, right? In this, momentum of Q is 0 because here the velocity immediately after decay, the Q is stationary. V is 0 means what? This part is 0. You don't require this one. So momentum of P should be equal to momentum of alpha. So momentum is what? Mass times velocity. So momentum of P, velocity is given. Mass, you can check here. This has 215 nucleons, right? Each nucleon has one atomic mass unit or AMU, right? One AMU mass is there. So you can substitute that one. 215 U multiplied by the velocity 3.2 into 10 to the power 5. This is the velocity momentum of P, which is equal to momentum of the alpha particle. Alpha particle has 4 nucleons, right? So the mass will be 4 times U multiplied by velocity, which is you want to find out the velocity of the or the speed of the alpha particles. Okay, so you can cancel U from here. So V will be equal to 215 multiplied by 3.2 into 10 to the power 5. This V4 will come here divided by 4. When you put it in the calculator, you will get 1.7 into 10 to the power 7. The answer will be 1.7 into 10 to the power 7 meter per second. So the answer will be 1.7 into 10 to the power 7. Okay. By reference to the direction of propagation of energy, state what is meant by a transverse wave. Okay, this question is common question. Sometimes they will ask transverse wave, or sometimes they will ask longitudinal wave. You can remember it with the 2 examples. Okay, this one I will explain here. So you imagine that there is a wall and a rope is tied at one end, and it is tied like this, and you're giving a disturbance at this point. Okay, you're giving a disturbance at this point. What happened? A wave is created in this one. This is transverse wave. And you consider a loudspeaker, okay, speaker, and she's creating sound waves, right? Sound waves, how it will propagate? The particle, okay, the particle in front of the vibrator, the diaphragm will compress the particle and the wave will propagate in that direction, right? So here you need to find out that you need to, in reference with the direction of propagation of energy. Direction of propagation of energy means the direction of propagation of wave itself. Okay, energy and the particle vibration. So we will check this one. You can see, if you consider a one particle, okay, in this transverse wave, okay, you are creating a disturbance here. One particle, this particle will always move up and down. It will vibrate. The direction of wave generated will be in this direction, right? This is the direction of propagation of wave. When you check what is the angle between these two, this will be 90 degree. And the same thing, okay, a wave is generated in this direction. This is the wave propagation. So a wave is propagating in this direction. If you consider one particle here, then one particle will vibrate, oscillate in this direction. So the direction of oscillation and the direction of propagation of waves are parallel to each other. What happened? It is considered as longitudinal wave. In this case, what is that? The direction of oscillation and the direction of propagation of wave or energy are perpendicular to each other. That the wave is said to be transverse. So in this question, you can write it as, what is that? Direction of propagation of energy is perpendicular to the oscillation of particle. Oscillation of particle. Okay. Next, a space telescope is designed to detect electromagnetic radiation with the wavelengths in the range 12 micrometer and 28 micrometer. You need to memorize these values, the wavelength of the electromagnetic spectrum. If it is micrometer, means these are infrared rays. Infrared waves, okay. A detector on the other space telescope detects an electromagnetic wave. The signal from the detector is transmitted to Earth and displayed on an oscilloscope, as shown in the figure. The frequency of the signal displayed on the oscilloscope is equal to the frequency of the detected electromagnetic wave. The frequencies are same. So the time-based setting of the oscilloscope, is 5 into 10 to the power minus 15 seconds per centimeter. Calculate the wavelength of the detected electromagnetic wave. You need to find out the wavelength of the detected electromagnetic wave. So oscilloscope output, you can see in one complete cycle, you check this one, 1, 2, 3, 4, 5, 6. 6 centimeter is there, right? So you have the time-based setting in that 6 multiplied by 5.0 into 10 to the power minus 15, you will get the time period, right? So because each centimeter is representing what? 5 into 10 to the power minus 15. So total 5 centimeters, 6 centimeters are there in one complete cycle. So you can find out the time period by multiplying 6 into that time-based setting. And here, one thing you need to remember that if you're calculating, or you don't need to convert this one, okay, into meters. Okay, a lot of students make this mistake in the paper. So you can see that you're getting the automatic answer will be in seconds only. So you check this one, 6 centimeter is multiplied with 5.0 into 10 to the power minus 15 second multiplied by centimeter to the power minus 1. This and this will get cancelled. Actually, automatically you're getting this in seconds. Okay, here conversion is not required. I have seen this thing. Okay, this mistake has been made by a lot of students. So just keep in mind that you don't need to convert centimeter into meter, and check that. Okay, if you have confusion, you write it and check it. Got it? So time, when you put this in your calculator, you will get it as, one second, 30 into 10 to the power 3 into 10 to the power minus 14 seconds. So this is the time period you require the wavelength. Wavelength, you know that V is equal to F lambda, which is equal to F is 1 by T, so lambda by T. So you require lambda, means lambda is equal to V multiplied by T. Since it is electromagnetic wave, the speed will be speed of sound. 3.0 into 10 to the power 8 multiplied by 3 into 10 to the power minus 4. Okay. Which is minus 14. Okay. So this is minus 14. So the wavelength will be 8 minus 14, 9. So 9 multiplied by this will 14 minus 6, right? 10 to the power minus 6. So this is the answer. Next question. A coherent source, okay, a coherent visible light of single frequency is incident normally on a double slit that produces a pattern of bright and dark interference fringes on a screen illustrated in this figure. So you can see that a double slit is illuminated with a light, and there is a interference pattern is formed on the screen. So it is all the values are given. The question is, there are 7 bright fringes. Okay, there are 7 bright fringes. What is that? 1, 2, 3, 4, 5, 6, 7 bright fringes are there. Explain how the pattern of bright and dark interference fringes are formed. The bright and dark fringes are formed, right? How it is formed? This is a 3-mark question. So 3-mark question, you need to phrase it properly. First thing is what? The light will diffract at the slits, right? It is diffracting at the slit and they are overlapping or superimposing or interfering on the screen. Then on the screen, it is not all bright, it is not all dark. Okay, alternate bright and dark pattern you are getting. Why that bright and dark pattern is there? Because of the phase difference. Okay, if the both, okay, from one you can see that I will show you. You take for an example, one wave is diffracted, bending, and it is hitting here from the source. The second wave is moving and hitting here. Okay, both are interfering. So your point, first diffraction should be there, second interference should be there on the screen. The third step is why it is dark and bright fringes. So you check this one. If you drop a perpendicular, that means the second wave has traveled an extra distance, okay, extra path. This is called path difference. Because of that, there is a phase difference at this point, okay? So 2 waves are moving and reaching there. If the crust is falling over crust, what happened? The amplitude will be maximum. You will get a bright spot there. If the crust is falling over a trough, what happened? It will get cancelled. So I'm talking about the sharp interference pattern, exactly in phase and anti-phase. In phase, if they are interfering, what happened? You will get a bright spot. In anti-phase, opposite phase, there, what happened? The amplitude will get cancelled and it will be a dark spot. So these points, 3 points you need to write. How can you phrase it properly? What is the phase difference? For a sharp interference pattern, I am telling, it should be 0 phase difference for bright and 180-degree phase difference for dark to get a sharp interference pattern. Okay, so you can phrase this answer. Light diffracts at 2 slits. That is the first point. And what happened? And light from each slit superimpose on the screen. So 2 points are done. Now you need to find out how the bright and dark fringes, on what basis, depending on the phase difference. Okay, if the phase difference is 0 degree, a bright means maximum intensity. Okay, Spot is false. It's not spot. Bright fringe you can write, okay? If phase difference is 180 degree, that means anti-phase, opposite direction, right? A dark fringe, which is minimum intensity, is formed. Okay. Next, the distance between the centers of bright fringe X and the the distance between the centers of bright fringe X and a bright fringe Y in this pattern is, okay, distance is given between two bright fringes, 10.2 mm. The slit spacing is 1.2 mm. The distance from the slits to the screen is 3.1 mm. Calculate the wavelength. This is easy question. Wavelength formula, you know that lambda is equal to AX upon D, right? So where lambda is the wavelength, A is the slit separation, and D is the distance between the sources and the screen. Here, thing is this one you need to find out. X means what? X actually is the separation or width of a fringe or single fringe, okay? But here, width of the single fringe is not given. They have given the distance between these two, okay? So you can count that 1, 2, 3, 4, 5. 5 bright fringes are there. But here you look at that, they have taken the center part, okay? That means here half is there. Here also one half is there. So total how much? 5 plus half, total 6 fringes are there. So that 10.2 mm is equal to 6 times X, correct? So that you can use here 6 times X is given by 6 multiplied by X is given as the distance, okay? 10.2 into 10 to the power minus 3, okay? This is mm. You can find out this X. X is equal to 10.2 into 10 to the power minus 3. Got it? So X value you got. Now you can find out lambda. Lambda is equal to A. What is the value for A here? The slit spacing is given as 1.2. Converted mm 10 to the power minus 3 plus into X value is 10.2 into 10 to the power minus 3. Then divided by, what is the value? This value you need to find out 6 also. X is equal to, divided by 6 is there. So 6 divided by 3.1. Okay. So 3.1, you put all these values in the calculator. What you will get? You will get it as 6.6 into 10 to the power minus 7 meter. Okay. Next. The light is replaced with a different visible light of shorter wavelength. State how the new fringe separation will compare to the original fringe separation. Okay. So you can see that you are changing. Everything is that setup you are not changing. You are changing only the light. So wavelength is decreased. The question is, you have the formula, wavelength you have reduced, right? So what happens to X? A and D you didn't change. That means lambda is directly, the wavelength is directly proportional to the slit separation. If you are reducing lambda, what happens? This will also get reduced. Okay, statement only. So what you can write? State only. Okay, reason if they're asking, if it is 2 mark, reason they're asking, since the lambda is directly proportional to the slit separation, it will decrease. You can write, now you can state only. So the new fringe separation will be smaller. Okay. Now, a stationary wave formed on the stretched wire AB is shown in this figure. P, Q, R are the points on the string. P, Q, R, these points we need to consider. On the figure, draw a cross to show the position of the node. Position of the node means what? Nodes are those particles which will not move from the mean position, which are stationary. That is why it is called a stationary wave. In progressive wave, what happened? All the particles in the medium are vibrating, right? But in stationary wave, what? Some particles are stationary there. So those stationary particles are called what? Nodes. So you can mark this point, any point you can mark, okay, which are stationary. Now, you need to state the phase difference between P and Q. P and Q, these two particles, if you take, if it is moving downward, what happens? At the same time, this will also move downward. Say this is moving 3 centimeter. This is moving, this also move 3 centimeter. What is the difference? 3 minus 3, 0. So if both are moving together in stationary waves, it will be 0. If you consider PQ and R, what happens? When it comes down, this will move upward direction. These are in opposite direction. So these are an anti-phase. The phase difference will be 180. Okay. You can remember this one. In stationary wave, the phase difference between any two particles can have only two wave things. Either it will be 0 or 180. If they are moving together, it will be 0. In opposite direction, it will be 180. Only two. In progressive wave, it can take any value from 0 to 2 pi. Here, only two possibilities. Stationary wave, 0 or 180. You can remember this. So we will move on to the next question. Define electric potential difference. Electric potential difference definition is what? Potential and potential difference is always energy per charge or work done per charge. Okay. Potential at a point they are asking means what? The work done from done on a charge from bringing it from infinity to that point in an electric field. Here it is potential difference. Simply they are asking, you can say that the energy transfer per unit charge. Energy transfer per unit charge. Between 2 points in an electric field. Or between 2 points in a circuit also, it is correct, okay? So energy transfer, energy per, or the energy means work and energy are same. Work done in moving a transfer or moving a charge from one point to another per charge, that is electric potential. Energy transfer per unit charge between 2 points in a circuit or in an electric field, both are correct. Okay. Then a cell of electromotive force, EMF, is given 1.8 volt and the internal resistance R is connected in parallel with a resistor of resistance 6 ohm and a filament lamp. Okay. So this is the diagram, circuit diagram. If the switch is open, that means this lamp is not a part of circuit now. Ammeter reading is 0.25 ampere. Determine the internal resistance of the resistor. Okay, so now you can see that the current I is coming from here. It is passing through 6 ohm. Then internal resistance also. R and the 6 in series only. So what is the maximum potential here? That is 1.8 volt, right? So you know that I is equal to V by R, right? Here, if you are applying in the first case, the circuit, the two resistance are there. Total resistance you need to find out. So here, what is the current flowing? 0.25, which is equal to, what is the potential available? 1.8 divided by, what is the R total? These 6 and R are in series, right? Only one common point is there between the resistor. So it will be in series. So you can write it as 6 plus R. Correct? Then you can say that 6 plus R, you can solve this equation. 6 plus R is equal to 1.8. This R is smaller, okay? Not capital R. This is the internal resistance. So this is R. 6 plus R is equal to 1.8 upon 0.25. 1.8 upon 0.25, when you put it in your calculator, that is 7.2 ohms. So R is equal to 7.2 minus 6, which is 1.2 ohms. So the answer will be 1.2. Okay, you understood? So the total resistance was 7.2. If you remove the 6 from there, the remaining will be the internal resistance of the cell. It's a simple question only. Next, at time t1, the switch S is in the figure is closed and shows the variation with the time and I. Okay, I versus T graph is given. This is the variation. State whether the EMF of the cell after T1. State whether the EMF of the cell after T1 is greater than, less than, and same as before T1. Okay, so actually you are closing this one. Closing this one means you are connecting a lamp in parallel with the 6 ohm, correct? So when you connect a parallel circuit, the potential difference across these 2 points will be same, which is exactly same as this one, correct? So, and they're asking about the EMF. EMF is what is the definition for electromotive force? The potential available at the terminals if they're not connected to the circuit, right? It is not going to change. So you can say that it will remains the same, right? State same. It is not going to change. The EMF value is not going to change. By considering the effect of the lamp on total resistance, okay, you remember you need to read the question carefully. On total resistance, the effect of the lamp on the total resistance of the circuit, explain the variation of ammeter reading. So you need to explain the variation of current with respect to the total resistance. So you need to identify what is the total resistance in T1, how it is varying with the current. So you check this one, 3-mark question. So 3-mark question means you need to analyze the graph. Before T1, what is that? You can see the current is constant. At T1, one variation is there, which is increasing. After T1, it is decreasing. So 3 situations are there. You will get 3 marks for that. Before that, what happened? Before the switch is closed, the resistance of the system, the resistance of the circuit is constant. That is why you are getting the current. At T, what happens? Suddenly you are closing this. That means a resistance is connected in parallel to the circuit. If you connect a resistance in parallel, the net resistance will decrease. To decrease the resistance, what is the method? To connect a resistance in parallel. So decrease in resistance means what? Resistance is decreasing means current will be increasing. Correct? So that is why at T1, the current is increasing. After that, what you can see the current is decreasing. Now, current is decreasing means the total resistance of the circuit increasing. Why? What happened? The moment the lamp starts glowing, what happened? The temperature of the resistance of the temperature of the lamp filament will increase. When temperature increases, what will happen? Resistance will increase for metals. So total resistance increases, what happened? The current will decrease. So you need to phrase this properly. First, what you need to do? Before T1, what is the variation? At T1, what is the variation? After T1, what is the variation? So that you write it in proper way, you can score the full marks for this. Okay. So first, before T1, I will check. Point by point, you need to write. Before T1, total resistance of the circuit is constant. So current is constant. So before means you have mentioned the first point. Next one, at T1. A lamp is connected in parallel So total resistance of the circuit decreases. So current will increase. Then what? After T1. After T1, due to increase in temperature, total resistance increases and current will decrease. So you need to write all these 3 points to get the full mark. Okay. Next question. State the name of class of group of fundamental particles that contains a neutrino. So neutrino, antineutrino, what is the cluster family? That is leptons, right? Leptons. A hadron P has a charge of plus 1e, where E is the elementary charge. The hadron P is composed of a down antiquark and only one other quark, okay? Identify the possible flavor of the other quark, okay? So what you need to memorize all these charges and values, okay? You know that down quark value, down quark, what is the charge? Minus 1 by 3e, right? So here it is anti-down, right? Anti-down means what? It will become plus 1 by 3e. Okay. The total charge is 1e. So you need to get 3 by 2, 2 by 3 more, right? 2 by 2. What are those quarks? Plus 2 by 3e will be up, charm, and tau, right? All these will have this challenge. You can take any one of this. It can be the possible flavor for this maybe up, charm, or tau. You can see this one when you add now. This is anti down plus 1 up. What will total charge? 1 by 3 plus 2 by 3, 1e, right? If you take a anti down plus 1c also, you will get this possible flavor. Top plus anti down also, you will get the same flavor, same charge, right? So these are the combination you can take. Now state what type of hadron it is. So here you can see that one anti-quark and one quark is combined, right? When one anti-quark and one quark is combined, what is formed? Mesons are formed, okay? State what type of hadron is this. Hadron is a meson. Got it? Now, nucleus Q undergo a radioactive decay from nucleus R, emitting an antineutrino and another particle X. Antineutrino and another particle X. Shown in the decay equation, okay? So state, okay, this type of question, you can see that if emitting antineutrino means what? Antineutrino means the particle emission, beta minus emission, antineutrino particle, right? Beta plus emission, neutrino particle. So you can write if an element Za is emitting a beta particle means what? Electron. Beta particle is electron, E minus 1, 0. Then what happens? And it will form another, sorry, another particle. So this one, Y I am taking. So what happens to the charge proton number? So Z minus 1, 1 is gone means it will become Z plus 1, right? So Z plus 1 minus 1, Z. A plus 0, A. You can see that this is plus, along with this anti-neutrino particle is also emitted. This is the equation for beta minus emission. This is electron, or you can say beta minus particle. Here, state what particle is represented by X. Now you can see that beta minus particle or electron. Compare the nucleon number of Q and R. So here X and Y you check A and A. Nucleon number won't change. So it will be equal. Okay. Then after that, you can see what is the next question. Compare the charge on Q and R. So this is Q, this is R, right? So Q is Z, R you can see Z plus 1. So it will be more, right? Charge on R will be more. Charge on R will be more. With this question, we finished 2024 Feb-March paper. Okay. If you find this video useful, please subscribe to the channel and press the bell icon for the notifications. Thank you.